Welcome friends, in this one let's answer the following question. It's the 1997 AP Calculus BC multiple choice section. It's question 11 from that test. You have basically an improper integral and you have to evaluate it. So, before we do anything else, we just want to decide on the method of integration. So in this case, when I do that personally, I kind of first rewrite this as just an indefinite integral, no limits, so I can anti-differentiate and then set up the rest at the end. I would have here x over the following. 1 plus x squared, and then this whole thing is raised to the second, dx. When I look at this, I kind of recognize that u sub can be used because 1 plus x squared and then x is kind of close to the derivative of 1 plus x squared. That's how I know. So for that reason, I'm going to write the following here. I'm going to set u equal to 1 plus x squared, and then differentiating du is 2x dx, and then dividing through by negative 2, I know that du over 2 is x dx. Now I can make replacements. Goes to the next stage, in other words. I would have the following. Indefinite integral, and then the part x dx can be replaced with d over 2, but dividing by 2 is like multiplying by 1/2, so you can put a 1/2 on the outside. And the next dx gets replaced with du, and the bottom part, that 1 plus x squared quantity squared, 1 plus x squared, that part gets replaced with u. So you have u squared, in other words. And then from here, this becomes 1/2. And then from here, next, we're going to get the following antiderivative of u raised to the negative second du. And then from here, I'm going to have 1/2. And then anti-differentiating here, I would have u raised to the negative second plus 1 divided by negative 2 plus 1, which then nicely would give me, let's see, negative 2 plus 1 in the bottom is just negative 1. Negative 1 times 1/2 is negative 1/2 out front now. And it's u to the negative first, which you can put in the bottom as just u this way. Lastly, what you want to do is just go back to the original variable x. So this now becomes negative 1 over 2, and the u gets replaced with 1 plus x squared this way. That's our antiderivative. Now, go back over here, and we can do the following. The limit as t approaches positive infinity, this way, of the definite integral. Let's see here, from 0 to t of this expression here, I can now write this as follows. I can say that this is the limit as t approaches positive infinity still of, and then I can just stick this in here as the antiderivative, like that, and then this is going to be evaluated between t and positive 1. Stick in, so in other words, limit as t goes to positive infinity, and then replace x with t, so it's going to be negative 1 raised over 2, and then 1 plus t squared this way, and then from the formula, you get negative, right? A negative. But this is also negative 1. So it's minus a negative, which in other words is a positive here, okay? 1 over 2, and then 1 plus. The second or lower limit is 1, so it becomes 1 squared in this position this way. Continuing, it's the limit as t goes to positive infinity this way. From here, we can proceed by doing the following. Just replace t with infinity. That's not official math, but it gets the idea across. You can just say negative 1 over 2, and then 1 plus infinity squared, this kind of situation, plus the second term there is 1 plus 1 squared. 1 squared is 1, 1 plus 1 is 2, 2 times 2 is 4. So there's a 4 in the bottom. And then here you have the following, negative 1 over infinity squared is infinity. Infinity plus 1 is infinity. 2 times infinity is infinity, so you just end up with infinity, in other words. Plus 1/4. Lastly, negative 1 over infinity. Remember, that basically goes to 0, so it goes away, which means the only thing that remains is 1/4. And this 1/4 thing constitutes the correct answer. In other words, the correct answer is part C. And that is it. So thank you, friends, so much for watching. Please leave a like. Please subscribe. I hope it's been helpful. I will see you in another video.